Have you ever wondered why a solid block of steel sinks instantly, yet a massive steel ship can float effortlessly on the ocean? It sounds impossible. Steel is much heavier than water. So why doesn't a ship sink? The answer comes from one of the oldest laws of physics, a law that controls every ship sailing today. The secret is not the material. It is the amount of water the object pushes aside. A solid block of steel has a very small volume. Its weight is concentrated, so it sinks immediately. But a ship is completely different. It is a giant hollow structure, filled mostly with air. The steel is heavy, but the entire ship's volume is incredibly large. This lowers its average density below the density of water. When the ship enters the sea, it pushes away a huge amount of water. The water pushes back upward with a force called buoyancy. If this upward force equals or exceeds the ship's weight, the ship will float. This is called Archimedes Principle. It is the foundation of modern ship design. The same steel can have completely different results. A solid steel block will sink to the bottom, but the same steel formed into a hollow ship can travel across oceans. The material is identical. Only the shape has changed. The real hero is not the steel itself. It is the air trapped inside the hull. That air reduces the ship's average density. This allows the hull to support its enormous weight. The larger the hull, the more water it pushes away, and the more water displaced, the stronger the buoyant force becomes. But floating is only the beginning. A ship must also stay stable while facing powerful waves. This depends on two important points: the center of gravity and the center of buoyancy. The center of gravity is where the ship's weight is concentrated. The center of buoyancy is where the water pushes upward. When the ship is upright, these two forces remain balanced. But when a wave makes the ship lean, the underwater shape changes. The center of buoyancy moves, creating a restoring force. This force pushes the ship back toward an upright position. This self-correcting system helps ships survive rough seas. However, stability has limits. If the center of gravity is too high, the ship can become unstable. That is why cargo is stored low and evenly distributed. The shape of the hull is also carefully designed. A wider hull creates more stability, but also increases water resistance. Engineers must find the perfect balance. The curved bottom of the hull helps reduce the impact of waves. It spreads forces more evenly and improves overall stability. The propeller creates thrust by pushing water backward. The rudder redirects the water, allowing the ship to turn smoothly. Inside the hull, watertight compartments provide protection. If one section is damaged, the others can still maintain buoyancy. But if too many compartments flood, the ship can eventually sink. Ballast tanks help maintain balance by controlling water inside the ship. Before a ship reaches the ocean, engineers run thousands of simulations. They test waves, turnt, and different loading conditions. Another important safety feature is the Plimsoll Line. It shows the maximum safe level a ship can be loaded. As a ship becomes heavier, it sinks deeper into the water. But loading beyond the limit can make it dangerously unstable. Ships do not defeat gravity. They simply work with physics. And that is why massive steel giants can continue crossing the oceans.